So today I want to talk about binary heap, how it is implemented, how is the insertion algorithm, removal algorithm, and how it is different from red black tree and other binary tree. So what is a binary heap? Binary heap is essentially a tree, but it has, just like a red black tree, it has properties that keeps it balanced. So in a red black tree you have these colors and these rules when inserting and deleting, which is quite complicated. But in a binary heap it is much simpler than that. There's only two property which gonna affect its deletion and removal, and it's also quite different in terms of implementation. So the first property is that the root is always the biggest node in the whole tree, and unlike other binary tree, in binary heap sometimes the left child is bigger, sometimes the right child is bigger. It's not always the left child is smaller and the right child is bigger, but the rule is that the root must be the biggest node and the parent must be bigger than both its child. As you can see here, 72 is bigger than both 26 and 66, and 34 is bigger than 9, and 72 again is the biggest node in the whole tree. The second property is that the tree must be complete except for the leaf. So as you can see here, what does complete mean is that it has no empty node except for the leaf. As you can see here, 34 doesn't have a right child. It is allowed because it's the leaf. But if the internal node doesn't have, like for example, if the root doesn't have, if it creates imbalance, then it is not allowed. It has to be complete. The inner node has to be complete. The only exception is the leaf. That's the properties. Now how does it affect the insertion? This is the insertion algorithm, so it's not as much different than binary tree insertion, but it's not exactly the same. So you just insert left first and then right, just as you would in other binary tree. But in here, you check with its parent, and then after that you check the parent with its root. So for example, right here you have 12. You wanna insert 34. Then you check with 12. Is 12 bigger than 34? If it is bigger, then you let it be. But if it's not, then you have to swap it because the parent has to be bigger than its child. So as you can see here, 12 is smaller than 34, so you swap it. If you insert 72 right here, then you would have to swap 72 with 34. But if like 72 have a parent, you have to check with its parent. If 72 is bigger than its parent, then you have to swap 72 with its parent. You just perform recursion up and up and up and up until you reach the root. If it is bigger than the root, then the root must be swapped with the new nodes. Now in binary heap you can only remove the biggest node. You cannot remove the smallest node. You can remove the smallest node, but there's this kind of the opposite kind of different type of binary heap. So this type of binary heap is that the root is actually the smallest node, not the biggest node. It's kind of the opposite, I think. But with the maximum binary heap, you can only remove the biggest node, and after you remove the biggest node, you replace it with the leftmost of the right child. As you can see, it's 7 right here. you replace 17 with 7, and then you perform recursion. You perform check to check whether 7 is actually the biggest node. Because if it is not the biggest node, then you have to swap it, just as we did before. This is actually quite a difference between a binary heap and other binary tree. Usually you would use linked list, set pointer left, pointer right, and such a thing, and then make it a tree. But with binary heap, how you implement it is actually by array. So instead of making using object and pointers, you use array to map the binary heap. Because the thing is, sometimes you have to check the uncle, which is not very easy with linked list, but much easier with an array. And it's also much faster because you can just calculate where a node would be, and you just access it, which is much more faster than using linked list and such. So say for example you are at D, you wanna locate D parent. How do you do that? You simply divide the index of D by 2. So the index of D is 4. You divide by 2, you get 2. And the parent is B. That's how you locate the parent. Same thing with F. 6. The parent is C. Index 3. With G also. 7 divided by 2 is 3 because it's 3.5, but if you assign it to integer, then it gets compressed because you cannot save decimals in integer. Now if you want to locate a left child of a parent, for example B, you just multiply it by 2. For example, you want to locate B. B has an index of 2, and the left children is D, which has an index of 4. Same thing with C. C has index of 3, multiplying by 2, you get 6. F is the children. For the right children, you just plus 1. 2 times the index of the parent plus 1. Same thing like the left child, except you have to add 1 to get the index of the right children. Now, what is the difference between red black tree, binary search tree, and binary heap? Now, it's quite clear, as you can see, that the deletion is different, and also how does it keep it balanced is very different. Now, the reason there's binary red black tree and binary heap alongside of binary search tree is because binary search tree can be unbalanced, and these are just basically algorithm on how to keep the tree balance. That's why there's such a thing as binary heap and red black tree. That's the primary reason, is that to keep the tree balance, but the way they do it is different. The properties are different. And that's all about binary heap. Thank you for watching.